Okay, dumako naman tayo sa masalimuot na mundo ng statistical analysis for difference tests, which are mostly based on probability distributions, no? Well, don't worry naman kasi we won't be doing the longhand methods. There are a lot of tables available out there na imbis na mag-punch pa tayo sa calculator, mag-compute pa ng mga z-values and p-values, they could just tell us based on how many panelists we have, the minimum number of correct responses needed for a significant result at a certain alpha level. But before we do that, though, there are important considerations for us, no? So, andyan yung testing for difference or testing for similarity as we've seen before. Ano ba yung actual examples ng testing for difference, no? For example, we want to look at the difference between fresh and stored samples, maybe as a function of time, para malaman mo how long mo pwede i-store yung samples before ka magkaroon ng changes in quality overall na madedetermine mo na difference. So parang shelf life yung tinitignan mo dito, no? Na if you consider the end of shelf life as if there is a perceptible difference from the fresh regardless of what attribute that is, then you would use a test for difference. Similarly, control versus treated sample if you are doing maybe modifications on your product, and then testing for similarity as is the case when doing ingredient substitution. So these usually need na parang mas wala dapat na changes kasi kapag nagpalit yung product mo, magreklamo yung consumers. No? Unless it's a change for the better, but in which case you won't need a difference test but rather an acceptability test. Or perhaps a combination of both in succession. Okay, again, the considerations for each is that if you are testing for difference, it's important to minimize the type 1 error. And when testing for similarity, it's important to minimize the type 2 error. Generally, para mas madali ang buhay mo, lakihan mo na lang yung sample size because we did mention that both type 1 and type 2 errors would be minimized by increasing the sample size to a substantial amount. Okay, so again, depending on whether you're testing for similarity or difference, then an alpha risk or beta risk would matter more. But nonetheless, to simplify things, there would be rules of thumb for the required number of assessors. So yung reasonably sized lang, kasi pag too big naman, like mong 100 or 200, logistically mahal siya. But if you have something as small as 10 or 15, then you are increasing those risks, no? So to simplify things, no, again, we want to make sure that alpha risk is low so that mababa yung risk na ma-reject natin yung null hypothesis. Beta risk is also low so that walang maging difference yung sample kung hindi talaga nag-exist when using it for similarity. And then the PD or proportion of distinguishers refers to the proportion of individuals in a population which could distinguish the product. So generally we want the PD to be large as well. But again, this is depending on the test. So typically when we combine the alpha and beta and PD, doon natin malalaman yung minimum number of assessors needed. So here is an example of the minimum number of assessors required for a triangle test based on the chosen alpha and beta risk combination, as well as the expected PD of your panelists. So take note as the PD goes down, then you need more panelists. But of course, for example, if we are expecting a PD of 50, which is very high, then if you want the alpha risk at 0.05, the beta risk at 0.05 as well, then we only need around 23 panelists to participate. Okay, the number of correct responses, of course, would be a different issue. So maraming paraan para malaman mo kung may significant difference nga sa isang kinonduct na discrimination or difference test. Okay, all of these are based on probability distributions. So you can use any one of them if you like. So for example, there's a lot of malt used for beer production, and the beer quality was analyzed by comparing it with the control sample. Difference tests were conducted using 20 panelists, and if out of the 20, 7 people tested the product correctly, what would be the significance test results? Okay, and what if triangle test was used instead? Right, so in this case, take note that the simple difference test has a probability of getting the correct answer at 50%, while the triangle test has it at just 33% because of the number of discrete response alternatives or choices they have. So the reason this is called the adjusted chi-square test is because of this continuity correction, the 0.5s over here. The rationale behind this is that chi-square distribution is continuous and observed frequencies from discrimination tests are integers. So therefore, there's a difference in the type of data that you can get. And because it is not possible for half a person to get the right answer, the statistical approximation can be off by as much as one half, and therefore to compensate for that, this continuity correction is added. Okay, first we want to understand the problem. Since we are using a new lot of malt for the production of beer, then in this case, ang ideal situation natin na gusto is accept H0. So in that case, medyo wala kang pakialam kung yung alternative hypothesis mo ay directional or hindi. Kasi ang gusto mo sanang mangyari ay an equal number of times statistically ay mapili nila ang either sample. So that is to say, hindi nila na-differentiate yung control doon sa new batch. Yun yung gusto mo mangyari. Kasi kung titingnan mo, yung alternative hypothesis mo, pag not equal sign yan, di ba, two directions yan. It could either mean on one extreme, lahat ng panelists nakuha yung tamang sagot, which means na differentiate nila yung sample. Or it could also mean na lahat sila nagkamali, which is it's a result that doesn't make sense. Statistically, significant siya kasi walang nakakuha ng tamang sagot, but then again, kung manghuhula ka, expected mo na 50% makakuha ng tamang sagot. So kung walang nakakuha ng tamang sagot, ang hirap i-explain kung paano yun, but there is something wrong with that type of dataset, so we won't care about that. So in this case, yung alternative hypothesis mo wouldn't really matter if it's px greater than py or px less than py, kasi ang gusto mong result is yung h0 lang ang matanggap. Okay? So if we plug in the values, assuming that this is a simple difference test, we will get a chi-squared value of 1.25, which is lower than the critical chi-square value based on the chi-square table with degrees of freedom equal to 1. So kapag yung chi-squared value is less than the chi-squared at the certain alpha chosen, you accept H0, and therefore samples are not significantly different. So suppose now we get the same results while conducting a triangle test, which has a lower required percentage of correct responses, no? Kasi statistically, you're comparing it to a probability of 1/3. Well, with your chi-squared table, the alpha value, the chi-squared value to obtain is 0.005, which is still less than the critical value of 3.841. Okay, so same decision pa rin, accept H0. So regardless if you conducted a triangle test or same different test, um, you would arrive at the same conclusion given that 7 people got it correct. However, this would not always be the case, as in certain cases, for the same number of panelists and same number of correct responses, a triangle test might have a different decision because yung cut-off mo for, yung kino-compare mo na probability is not 0.5 but 0.33. Pag binomial test naman, of course, you use the binomial table. This one has n equals 20, and these are the number of correct responses. As usual, we subtract to get the probability at that point, you subtract the cumulative probability from the one lower. So, yung minus mo yun sa 0.6, yun sa 6. Okay, so for triangle, for same different test, you get 0.0739, and for the triangle test, you get 0.1820. Either ways, lahat sila ay greater than your alpha of 0.05, and therefore, you would arrive at the same conclusion that you would have to accept the null hypothesis. Because statistically speaking, we couldn't really say with certainty that yung pagsagot nila doon, pagkuhan lang ng tamang sagot ay hindi due to chance. So when you have a larger number of panelists, we can use the z-test on proportion, okay, where x is equal to the number of correct responses and the small letter n is a total number of responses, while the probability is either 1/2 or 1/3 depending on whether it's a paired comparison test, duo trio, or 1/3 if it's a triangle test. And then the q is simply the alternative probability, or equal to 1 minus p. So if you input in this equation, you get a value for. In this case, suppose a duo trio test was conducted using 50 panelists and 35 people got the correct responses. We want to know if this is enough to establish a statistically significant difference between the two samples. As always, this is a probability hypothesis, wherein the null hypothesis is that there is an equal probability of choosing either sample, and then in this case, our desired outcome, if for example we want to establish that there is a difference, would be that the probability of garnering a correct response would be greater than 50%. As such, we could, from the z-table cumulative, approximate the critical value to be at 1.645, which is equal to the z-value of 0.95. Okay, and then since we computed the z-value for this information and got a value that's higher, then the probability of that happening, 1 minus p yung tinitignan natin, no, dito, is obviously less than 0.05 based on the 1 minus p nito. So that means we accept the alternative hypothesis that the people really do observe a difference. Okay, in this case, 35 over 50 is well over 50%, no, of the population. So mukhang ano naman siya, sound naman yung conclusion. So ito naman yung medyo idiot proof na pwede nating gamitin, no? Minimum number of correct judgments to establish a significance for paired comparison and triangle test depending on the number of panelists and the chosen probability or alpha levels. Okay, so we just look at, let's say if you have 20 panelists, in this case you're conducting a paired comparison or duo trio test. If your alpha is 0.05, then you need 15 responses to to establish statistical significance. On the other hand, for triangle test, medyo naputol. Sabihin natin may 15 ka na individual sa triangle test. Then you need 9 out of 15 to get the correct to establish statistical significance. As you can see, habang lumalaki yung number of trials, mas nag-a-approach dun sa probability natin yung number of panelists required to have a correct answer. Now, for example, at just 5 panelists, you need 100% correct responses to establish statistical significance. On the other hand, at 20, you just need 75% of the panelists to to have a correct answer for the statistical significance to be established. Okay, this is just the quantified or equationized, so to speak, version of the table. In case you have numbers that are not on the table, then you could use this one and again compare it to the probability at that to compare it to the z value corresponding to the probability related to your alpha, which is usually around 0.95. Right now we're looking at situations wherein we are testing for similarity. Again, in cases like this, the favorable outcome would be for the null hypothesis to be accepted. Therefore, you would want to minimize your errors accordingly. Okay, so earlier you've seen the alpha, beta, and PD in the previous table that I've shown. So this is how they would use it in a practical setting. So for example, because you're testing for similarity, you want your beta risk to be lowered, and you want a very strict beta risk lowering to 0.1% or beta equals 0.001. So this is a far cry from the 5% or 1% that we usually select. Okay, ito yan, yung 5%, 1%, you're choosing a more safeguarded 0.1%. Okay, so then you have to presume this PD, which is the if you were to take the whole population of your qualified panelists, let's say in the Philippines or in the world, this is the expected chance to get the correct answer or detect the actual difference. Okay, so of course, unless you have data, this could be arbitrary, but again, if you make it higher, then you're raising the risk of your errors as well. Kasi paano kung PD 50 ang pinili mo, pero kung in reality pala 20% lang yung PD, then well, you're screwed, no? So they chose a conservative PD of 20% in this case, and then a modest alpha risk of 10%. So that would result to 260 assessors. Okay. On the other hand, if you compromise an alpha of 20% and a beta of alpha of 0.2 or 20% and a beta of 1% of 0.01 and an presumed PD of 30, then they would only need 64 assessors. Okay, so if you have some free time, you could try doing this on Excel. You can just follow the instructions to have your test sensitivity analyzer. Okay, or if you have the magic of the internet, there are perhaps websites that can do this for you. You just input the variables and then it will output you whatever you desire regarding the number of panelists that you would need and the expected sensitivity from it. Alright, so to make life easier again, such tables like these exist. So you just have to look at to be able to interpret results, first you have to look at how many respondents or what your N is. Okay, you need to look at how many people got the correct response, and then you need to revisit your alpha values. So in this case, with 66 respondents at an alpha of 0.2, the minimum number of responses needed to establish significant difference is 26. However, you only answered 21. Therefore, you accept the null hypothesis. But since in testing for similarity, it is the null hypothesis that you desire, so in this case, pwede mong sabihin na successful ka doon sa whatever ingredient substitution mo. Okay? And that is how you interpret, analyze and interpret, no? Yung data na na-measure mo.